Good morning, Dr. Farhan. My name is Yen Thong. My team members are Tay Wei Jian, Chia Jee Liang, and Jun Hong. Today, our group is going to present our VTK project. This project is mainly divided into part 1 and part 2, and part 1 is mainly about the isosurface and also the ray matching. So in the part 1 of this project, we are using 4 different datasets, which is the frog, head, teapot, which is the dataset provided by doctor, and also one external dataset, which is the MR brain. So in this video, I'm going to demo the head dataset to you. Okay, so when I run the program, it is default in the ray matching mode. So when we press on the key S, it will change into the isosurface mode. So the key S is using to alternate between two random modes, which is the ray matching and also the isosurface. Then in this isosurface mode, we can use the different key to change its isosurface value. Okay, so we have two different keys, which is I and K, to use to change the value of the isosurface. So we can use the key I and K to change the value of the isosurface. For example, for I, it is using to change the value of the first isosurface, while the K is used to change the value of second isosurface. The small letter I is used to decrease the isosurface value, and the capital letter I is used to increase the iso value by 100. Then the key small letter k is used to decrease the ISO value for the second surface by 100, whereas the key capital K is used to increase the ISO value by 100. That's all for my demo. Next, I'll pass to my team member Tay Wei Jian to demo the ray matching.
So next one, I will be presenting the ray matching algorithm part. So this one is the ray matching algorithm rendering project. So we can use the plus and minus key to increase the ray step or decrease the ray step. And then we can also change the position of the points in the color transfer function by pressing the key slash. And then we can select the points in the transfer function by using the key 0 to key 9. So for now, I will select the second point in the transfer function and then adjust the position by using the minus and plus key. So as we can see here, the color orange or yellow is decreasing the position and also increasing the position. And then we can also change the position of the points in the opacity transfer function by using the key dot. And then same as the color transfer function, we can select the points in the opacity transfer function by using 0 to 9. So I can select the second point and then decreasing the position. So as we can see, more parts will be rendered in the window. And then when I press plus, less object will be rendered in the screen. So that's all for the ray matching part. Thank you.
For part 2, this is the result of the headshot visualization. I tried an error and used a scale factor of 1.3 to get this clear headshot visualization of test data 1. For test data 2, the scale factor is 0.8 and this is the result. For carotid.vtk, the scale factor is 1 to get this result. As for the glyph-based visualization, the scale factor for the test data 1 is 1.2 and this is the result. For test data 2, the scale factor is 1.5 to get this result, and this is for the carotid.vtk. To obtain this result is by setting the scale factor to 0.5. Thank you.
Hi doctor, my name is Chia Jee Liang and my job in this group assignment is to do the streamline and also the sampling point. So for streamline part, I use VTK stream tracer to insert the starting point for the streamline. I also apply a regular grid for streamline visualization. So this is the result for test data 1. This is the result for test data 2. And this is the result for carotid.vtk. So next I will talk about the sampling points. So actually the VTK point class is no longer exists in the documentation. So we need to insert the sampling point manually. So in this case, I use a loop to insert the sampling point. So the red one is the sampling point, the blue one is the streamline. So this is the result for the test data 1. This is the result for test data 2. And this is the result for carotid.vtk. So for in this case, the sampling point is blue color and the streamline is red color. So that's all for our presentation. Thank you.